In this video for the Section 8.2 activity, we're going to go through probability problems that involve and or. So we're going to start with this example where we have a survey involving 1,000 university students. 750 students own laptops, 450 owned cars, and 350 owned both cars and laptops. So we're going to start with filling in the two-way table. I'll start with the fact that 1,000 students were involved in the survey in total. I know that 350 owned both cars and laptops. I know that the total number of students that had laptops were 750. And so the number of students who had a laptop but no car would be 400 if I subtract. The number of students who owned cars was 450. And so that means that 100 students owned a car but no laptop. And since 750 had a laptop, that means the total without a laptop was 250. Since 450 have a car, the total number with no car is 550. I'm just subtracting those from 1,000. And so this missing box here is going to be 150 because 400 plus that number is 550 and 100 plus that number is 250. Both of those check out to be 150. And this should look similar to a set notation problem that we discussed earlier. So now we want to find probabilities. So if we randomly choose a student out of the 1,000 students, what is the probability that that student has a laptop? Well, since there's a total of 750 students with laptops out of a total of 1,000 students surveyed, that's going to be a probability of 75%, or 0.75. What is the probability that that student has a car? Well, there's a total of 450 students with cars out of my 1,000 students. So 450 divided by 1,000, which is 0.45 or 45%. What is the probability that a student doesn't have a laptop? 250 students did not have laptops out of 1,000. So that probability is 25%. And what is the probability that the student doesn't have a car? That's going to be 550 divided by 1,000, or 55%. And you notice that the probability of laptop and no laptop and the probability of car and no car, if you add those two numbers together, you get 1. And that's because a student has to fall in one of those two groups. So there's no way to exist in a situation where you either have a laptop and don't have a laptop. You're not in one of those two groups. Same thing with the car. A person has to fall into one of those two groups. They either have one or they don't. There's no middle ground there. So now we're going to find probabilities for two events occurring. So the first one is the probability that the student owns both a laptop and a car. We can see that that's 350 students out of our 1,000 students. So 350 divided by 1,000 is 0.35. What's the probability that the student has a car and no laptop? Well, has a car and no laptop is 100 students out of 1,000. So that's 10%. The probability of having a laptop and no car, have a laptop, no car, that's 400 students. So 400 divided by 1,000, or 40%. And finally, the probability of having no laptop and no car, that's 150 students out of 1,000, or 15%. Question 4 says, is probability of laptop or car equal to probability of laptop plus probability of car? Why or why not? So if we look at these probabilities, the probability of owning a laptop is 0.75, and the probability of having a car is 0.45. So we can see that it's not going to work because probability of owning a laptop plus probability of owning a car is going to be more than 1. 0.75 plus 0.45 is 1.2. and probability cannot be more than 1. So as we talked about earlier, a probability of 1 means that something is guaranteed to happen, but probability values cannot be higher than 1. So that's kind of a numbers explanation of why this side doesn't work. The reason that it doesn't work is if you look at our table here, probability of laptop, probability a person has a laptop, is adding these two boxes, 350 plus 400. And the probability of having a car is the 350 plus 100. So we've counted these 350 students twice. And so that's what makes our value too big. And so now we're going to put the probability values in our Venn diagram here. So we have a circle for laptop and a circle for car. The overlap is going to be people who have a laptop and a car. So that is 0.35, 35%. And then in this box are going to be the probability of having a laptop but no car. So these are in the laptop circle but not in the car circle. So laptop and no car, that's going to be 40%. And then this box is going to be a car but no laptop. So they're in the car circle but not the laptop circle. Car, no laptop is going to be 0.1. And then this box is going to be no car and no laptop. Not in the car circle, not in the laptop circle, and so that's going to be 0.15 or 15%. And so where is car and laptop in the Venn diagram? It's the overlap area. So it's this little part in the middle where the two circles overlap. Car or laptop is the total area of the two circles. So everyone in this area, they have a car or they have a laptop or they might have both, but they're guaranteed to have at least one of the two items. If they don't have one of the two items, then they're going to be outside of the two circles. So the total area of the two circles. Or in other words, both circles, including the overlap area.